Hello, this is Dr. Mears, and today we are going to learn about how to write a quadratic function from a graph. A couple things that I want you to write down first before we get to this actual activity are the different forms of our quadratic functions. And I want to point out the two that we're going to use today. So here we have three. We have vertex, intercept, and general form. Now, if you haven't watched my video about these forms, you can go back and watch that on YouTube, on my YouTube channel. The ones that we're going to use today are going to be vertex form and intercept form. So if you have a piece of paper, a little side note, you can copy those two down because those are the ones that we're going to be using today. All right, back to our activity. So we have some steps here on how to write a quadratic function from a graph. So we're going to be writing an equation. I provided this as a little checklist for you that you can use if you like it. The first thing that we're going to do is write down the names of the points that are given in the graph. Then we're going to match the equation to that name, to those names that we wrote down. Substitute the numbers into the equation. We're going to have to find A by using substitution, and then we're going to be rewriting the equation in its entirety. Okay, our first example, number 1. Use the information shown in the graph to find an expression for the quadratic function. Now, I wrote expression here. I took this out of the book. Let's write equation. An expression doesn't have an equal sign. An equation does. So let's just change those directions because I do want the entire equation written down and not just the expression. Okay, we have a graph here. So number 1, write down the names of the points given in the graph. So I don't want just the points. The points are already labeled. I want the names. So if we look here, the first thing that we have, so our first step is going to be we have x-intercepts. We have 2 of them. The first one is at 3, 0, and the second one is at negative 4, 0. I'll just write that down, or the first one's at negative 4, 0, and the second one's at 3, 0. I like writing them from left to right. All right, what else do we have? Number 2. It does look like this would be at the vertex, but it's not. The vertex is actually right where this pencil is. We actually have the y-intercept. And the y-intercept is 0, negative 24. Okay, so now that we have the names of our points, we have to do number 2. Match the equation to the names we just wrote down. So as I bring my paper over here, we have vertex form and we have intercept form. We're not going to be using general form yet. So in the vertex, if we had the word vertex, we would be using that. We don't. What do we have? We have intercept. In this intercept form, this is actually talking about our x-intercepts. And we have that, x-intercepts. So we're going to be using this one right here. So number 2, this was not number 2. Number 2, we are going to be using our intercept form and substituting the numbers in. All right, so what intercepts do we have? Here are our x-intercepts. So this is going to be P and this is going to be Q. So we have P and we have Q. And so we're going to, that's checked, substitute the numbers into the equation. So number 3, y equals a, x, now be careful because this is a negative 4. And remember, when we either put it into the equation or pull it out, it's going to be flipped to its opposite. So because this is negative 4, it's going to go in as plus 4. Again for Q, it's x minus q. So this is a positive 3, so it's going to be put in as a minus 3. And when we start solving these equations, you're going to see that it comes full circle. You're going to absolutely understand why this is happening when we start solving equations, but that's coming up. Okay, so we substituted the numbers into the equation, and now we need to find our last variable, and that's a. We need to know what number this is. So find a by choosing another point to substitute in and solve. So we used our x-intercepts, we have this other point, we have our y-intercept, so let's substitute this in. So they give us x and they give us y. So where we see the letter x, we're going to put a 0. So I see an x here. I see an x here. I don't have a. Where I see a y, I'm going to put negative 24, negative 24. And hence, we're substituting in the numbers for the variables. So if you notice, I now am able to solve for a, which means get it by itself. So I'm just going to do a couple things. The first one is parentheses equals a. 0 plus 4 is 4. 0 minus 3 is negative 3. I can multiply these two together. Negative 24 equals, instead of putting it in the behind a, I'm just going to put it in front, negative 12a. You can rewrite it like this. You could put the negative 12 in back, but this is multiplication, and when it is multiplication, we usually write the number to the left side of the letter. Now with solve, you got it. Divide both sides by negative 12. The negative goes with it, and a is going to come out to be 2. Yay, we found a. Check. And our last one is to rewrite the equation. So now that we have our intercepts and we have a, I'm going to star these two things. This is what we need. We're going to rewrite our equation. So this was number 4 and number 5. Y equals, we have a, 2, times the quantity x plus 4 times the quantity x minus 3. And this right here is our answer. This is the equation to this graph. So if you put this in your graphing calculator, this is what the graph is going to look like. It's going to cross the x-axis at negative 4, 0 and 3, 0, and it's going to have a y-intercept of 0, negative 24. Pretty neat. Okay, let's go on to our second one. Yes, so I did that. I love checking my check boxes off. Let's go to the next one. Okay, use the information shown in the graph to find an expression for the quadratic function. Number 1, write down the names of the points given in the graph. So let's go to the graph. So let's see. The first point we have is a y-intercept, and that's at 0, 4. The second point that we have is down here. I'm noticing that it's the vertex, and that's 2, negative 2. So now that I have the vertex, I'm going to go back here. Which one does that match up to? That matches up to vertex form. That's why I want you to write the names down, because it gave you vertex, so we know we're just going to use this one. There is no guessing game. Write the name down, match it to the correct one. So let's write down vertex form. Y equals a, x minus h squared plus k. The next one is going to be substitute the numbers into the equation. So here we have h, here we have k. Remember, our vertex is hk. If you want to go back to watch that video about the forms, you can. So let's substitute the numbers in. Y equals a, x. Now be careful, this is minus. So every time we pull it out or put the number back in, we have to change this to its opposite. So right here it's a positive. So you're right, it's going to become minus 2. Don't forget your square. Now this k, it's positive here, which is fine. So whatever number this is, we're just going to put it in. So it was negative 2, so it's just going to become minus 2. So you just have to remember it's the each one that you have to worry about. Okay, we're not done yet. We still need this variable a. We use the vertex. So now we're going to look to the to the y-intercept. Here we have x and y. And wherever we see an x in here, we're going to put 0, 0. I'm going to rewrite everything over. So I just took the x out and I put 0. Everything else stayed the same. Where I have my y, I'm going to replace it with my 4. Now I'm going to go through and solve. You can, if actually you can't. Don't just put this in the calculator. It won't work because we have this minus 2. So you actually have to do this in a couple steps. The first one is going to just be doing this part right here. That has to be first, because we have this minus 2. And we can actually do this a couple different ways. We could have added 2 to both sides. You know what? That might be better for everybody. So bring this minus 2 over first, okay? Or if it's a plus, either way. But get this onto the other side. So let's add this. Let's just get it out of there because I don't want it to mess anybody up. So I just added it. I did inverse operations, added it. So 4 plus 2 is 6 equals a times 0 minus 2 squared. Now what you could do is that in your calculator if you would like. 0 minus 2 squared. And that is going to give us 0, negative 2 squared is 4. So it's going to be 6 equals 4 times a. So in the calculator, you're just doing that part and you should have got 4. Negative 2 squared is positive 4. And then, yes, we have to divide both sides by 4. So we have 6/4. Now here's the thing, you can change that to a decimal. That's absolutely fine. If you want to do 1.5, that's absolutely fine. If you want to leave it as 3/2, you can do that as well. And our last step is to rewrite the equation. Y equals 1.5, we need that A, times, and then we're going to need the vertex, x minus 2 squared minus 2. I like to go back to this one right here because all I'm doing is I'm just substituting my A in, and I'm just rewriting down what's here. But those are the two things that you have to use to write this equation. Now, I just want to do a little side note down here. When we were at this step, just for solving purposes, I decided for this step when I was solving, I decided to add 2. Now, if you liked that method, stick with it, stop the video. If you understand it, walk away. But if you want to know further what you would do if you didn't do this first, this is what you would do. First, you would just do this part. And so this would be negative 2 squared, so that would give us 4a. And I would have you write it with the 4 in front. So this becomes 4. And then I'd have you do minus 2. Then inverse operations, we can add 2 to both sides. This becomes 6 equals 4a, and we are back to that same 1.5. So either way works. If you want to take care of that first and put the number in front of a, that's fine. If you want to add it first, bring it over to the side so it's out of there, you're going to get the same answer no matter what. But all in all, what are we looking for? We're looking for our equation, y equals 1.5 times the quantity x minus 2 squared minus 2. If you put this in your graphing calculator, you're going to get that. If you want to write it as a fancy function, you just change y into f of x and rewrite everything on the right side. There's your function. There's how you put in the calculator with y. Either way works. This has been writing an equation from a graph. Thank you.